This is a question from artificial intelligence. We are given two lists and we are asked to match list 1 with list 2. So let's see each option one by one. First one is hill climbing. Hill climbing is a heuristic search algorithm that continues to move towards the direction of increasing value to find the peak of the solution space. So first of all, let's see hill climbing. It is a heuristic search algorithm. And it moves towards direction of increasing value to find peak of solution space. To find peak of solution space. So the options here are dealing with space complexity. So in hill climbing, we need to keep track of the current state and a small number of neighboring states for comparison. So it does not store all previously visited state, leading to a constant space requirement. So it requires only order of 1 space complexity. So A maps with 3. Now from options itself, we can say B, C and D are already eliminated, but let's see rest of the options. Now next one is best first search. It is a search algorithm that explores a graph by expanding the most promising node chosen according to some specific heuristic. So here we in best first search, what happens is explores a graph by expanding most promising node based on heuristics. So this algorithm maintains a priority queue of nodes to explore. In the worst case, it needs to store all nodes that are generated, leading to an exponential space complexity based on its branching factor and depth m. So here the complexity is defined by the branching factor and depth m. So the exponential space complexity required is b to the power d, where b is the branching factor, b represents branching factor, and d represents depth. So b power d. So b maps with 1. Now let's see our options. A maps with 3, B maps with 1. Next one is A star search. A star search is an informed search algorithm. A star search is an informed search algorithm that combines the cost to reach a node and the estimated cost from the node to the goal to prioritize nodes. Here also the complexity required is b to the power m. Here what happens is A star requires maintaining all generated nodes in memory to ensure the optimal path. So here also the complexity will be exponential time complexity. C will be mapped to 4. Next one is depth first search. DFS is an algorithm that explores as far as down a branch possible by backtracking to explore with other branches. Basically, the time complexity required for DFS is order of B into M. Here what happens is DFS needs to store the current path from the root to the deepest explored node, which requires a memory proportional to the depth m. Here depth is denoted as m. Can denote depth as m, or we can denote depth as d, and a branching factor b. So DFS has a time complexity or has a space complexity of order of b into d. So d maps with 2. So from the options, A maps with 3, B maps with 1, C maps with 4, D maps with 2. So option A is the correct answer here.